Good morning. Today our new class is types of full wave rectifiers and center tapped full wave rectifier and also advantages and disadvantages of center tapped full wave rectifier. Center tapped full wave rectifier. Next, recap of this presentation. In previous class we discussed about half wave rectifiers, efficiency of half wave rectifiers, advantages and disadvantages of half wave rectifiers. These three topics are completed in previous class. Okay. So now next, objectives of this presentation. On completion of this period you would be able to understand first of all, so what are the types of full wave rectifiers and center tapped full wave rectifier and advantages and disadvantages of center tapped full wave rectifier and also summary. Okay, these topics are discussed now one by one. Okay, so in these topics the first topic is types of full wave rectifier. In full wave rectifier, current flows through the load in the same direction for both half cycles of input AC voltage. For both half cycles of input AC voltage. Okay. So, but in case of half wave rectifier, so current flows through only one half cycle, one direction, one half cycle. Okay. But in case of full wave rectifiers, current flows through the load in the same direction for both half cycles of input AC voltage. Okay. So, the commonly used full wave rectifier circuits are two types: center tapped full wave rectifier and full wave bridge rectifier. These are two types are commonly used in full wave rectifiers. Okay. So, in these two types, so the first one is the center tapped full wave rectifier. Okay. Now discussed in center tapped full wave rectifier. Okay. So, a center tapped secondary winding AB. This is the circuit. This is the circuit of center tapped full wave rectifier. This is the circuit of center tapped full wave rectifier. A center tapped secondary winding. So, we can first of all we can apply the AC input voltage. AC supply 250 volts 50 Hz of AC signal is applied to primary winding of transformer. So, this center tapped full wave rectifier consists of two diodes, one load resistor, one transformer. Okay. So, first of all we can apply input AC signal to the primary of transformer. So, this signal goes to secondary winding of transformer by using mutual induction. These two parallel lines is nothing but mutual induction. Okay. So, now the AC supply is in the secondary winding of AB terminals. AB terminals. Okay. So, a center tapped secondary winding AB is used with two diodes D1 and D2. These two diodes are connected so that each diode uses one half cycle of input AC voltage. D1 is uses positive half cycle, D2 is uses negative half cycle, or D1 is uses negative half cycle and D2 is uses positive half cycle. Depends on the polarities of AB terminals. Depends on the polarities of secondary winding of AB terminals. Okay. Next, in other words, D1 utilizes AC voltage appearing across upper half of secondary winding OA. D1 uses or utilizes the AC voltage, that AC voltage appearing across the upper half of secondary winding for rectification. Upper half means OA. So, while the diode D2 uses lower half of secondary winding OB, lower half of secondary winding OB for rectification. Okay. This is the input and output waveforms of center tapped full wave rectifier. Observe these waveforms. So, input first waveform is the input waveform. Vi is input voltage, that is the input waveform, that is sine wave, that is applied to the AC supply of primary transformer of center tapped full wave rectifier. Okay, so here the AC voltage across the secondary winding, AC voltage across the secondary winding changes, secondary winding AB changes polarities after every half cycle, after every half cycle. So during positive half cycle of input AC voltage, so observe the input signal, so positive half cycle, during positive half cycle of input AC voltage, the transformer secondary winding NDA becomes positive and NDB becomes negative. NDA becomes positive, NDB becomes negative. Okay, so observe this. A is positive, NDA is positive. Positive is connected to diode 1 of anode. Positive is connected to anode. Anode means positive. Positive is connected to positive of diode 1. So what about B? What about B? B is negative. So negative is connected to anode of diode D2. And negative is connected to positive. So positive, NDA, positive is connected to positive. That's why diode D1 is forward bias. Here B is negative. Negative is connected to positive. So this is reverse bias. Diode D2 is reverse bias. D1 is forward bias. D2 is reverse bias. This makes the diode D1 forward biased, diode D2 reverse biased. Therefore D1 conducts while D2 does not conducts. Therefore the current flows through D1. So because D1 is in short circuit, okay, that's why current flows through the diode D1 to the load resistor. So D2 is reverse bias, that's why it is open switch. There is no current flows through the diode D2. The conventional current flows through it is D1 and load resistor RL, okay, and upper half of secondary winding. Hence the output appears across load resistor, that is a positive half cycle is present. Observe the waveform, output voltage, second waveform. So D1 is conducts during positive half cycle of D1 is forward bias. So this is closed loop, that's why it conducts current, it flows through the current through the load resistor. Okay, next, so observe the third waveform. During negative half cycle of input AC voltage, the transformer secondary winding A becomes negative, B becomes positive. A becomes negative, B becomes positive. Observe this. So during negative half cycle of input AC voltage, the transformer secondary winding A becomes negative, B becomes positive. A becomes negative, B becomes positive. This makes that diode D2 is forward bias. A is negative, so negative is connected to anode of diode D1. So that is negative is connected to positive. That's why D1 is reverse bias. So D1 reverse bias means it is in open switch. That's why there is no current flows through D1. Okay, so next, so B is positive. Positive is connected to anode of diode D2. Anode means positive. Positive is connected to positive. So diode D2 is forward bias. Okay, so therefore D2 conducts. This is closed loop. D2 conducts. D1 does not conducts. The conventional current flow is through the D2, through load resistor RL. So the lower half winding, hence output appears across load resistor at the same direction. That's why negative half cycle appears across load resistor in positive cycle also. Observe the third waveform. So this is D2 is conducts during negative half cycle. D2 is forward bias. D2 conducts. So appears positive half cycle because it both are in same direction. So then observe last waveform. So due to D1 positive half cycle forms and due to D2. So negative half cycle goes to positive half cycle because both are same direction through the load resistor. Okay, so the last waveform is nothing but the total output of center tapped full wave rectifier. Center tapped full wave rectifier. Okay, center tapped full wave rectifier. It may be seen that current in the load RL is in the same direction for both half of the input AC voltage. Therefore, DC is obtained across the load resistor RL. So observe this. So this is forward bias. D1 is, observe the during positive half cycle, D1 is forward bias, D2 is reverse bias. Okay. So D1 act as a closed switch. So that's why current flows through D1 through load resistor. Okay, so next, during negative half cycle D2 conducts current. Okay, so D1 is open switch and D2 is closed switch. Therefore, the current flows through D2 through load resistor in the same direction. That's why positive half cycle is appears at the load resistor. That is the output. Okay, this is nothing but the operation of center tapped full wave rectifier. Center tapped full wave rectifier. Okay, next, advantages of center tapped full wave rectifier. Advantages of center tapped full wave rectifier. So the first advantage is output DC power is high compared to half wave rectifier. So output DC power is high. And the second advantage of center tapped full wave rectifier is efficiency is high. So that is 81.6% compared to half wave rectifier. Half wave rectifier efficiency is only 40.6%. But in this case, full wave rectifier, center tapped full wave rectifier efficiency is 81.6%. Next, the third advantage of center tapped full wave rectifier is ripple factor is less. That is 0.48. Ripple factor is less, that is 0.48. These three are the advantages of center tapped full wave rectifier. Then next, disadvantages of center tapped full wave rectifier. Disadvantages of center tapped full wave rectifier. The first disadvantage of center tapped full wave rectifier is it is difficult to locate the center tap on the secondary winding. It is difficult to locate the center tap on the secondary winding because both are in same direction. So that's why it is difficult to locate the center tap on the secondary winding. Next, second disadvantage of center tapped full wave rectifier is the DC output is small as each diode utilizes only half of the transformer secondary voltage. The DC output is small as each diode utilizes only one half of the transformer secondary voltage. Each diode utilizes only one half of the transformer secondary voltage. So if diode 1 utilizes one half voltage, so other voltage is loss. Okay, then diode D2 utilizes on a one half voltage, then other half voltage is losses. Okay, next, that is the disadvantage of center tapped full wave rectifier. Next, third one is the diodes used must have high peak inverse voltage. The diodes D1 and D2 used must have high peak inverse voltage. Okay, peak inverse voltage is very high because both diodes are uses must high peak inverse voltage. These three are the disadvantages. Of center tapped full wave rectifier. Okay, so full wave center tapped rectifier and also advantages, disadvantages are completed. Okay, next, summary of this presentation. We have seen types of full wave rectifiers, center tapped full wave rectifiers, advantages and disadvantages of center tapped full wave rectifier are completed. Okay, next, Frequently asked questions may be asked. Next, frequently asked questions may be asked. Explain the operation of center tap, full wave, rectifier, circuit with waveforms. Okay, this question may also be asked. Draw the circuit of center tap, full wave, rectifier, and also draw the input and output waveforms of center tap, full wave, rectifiers. Okay, next, second question. Write the advantages and disadvantages of center tapped full wave rectifier. Write the advantages and disadvantages of center tapped full wave rectifier, and may also be asked in this question, what are the applications of center tapped full wave rectifiers? What are the applications of center tapped full wave rectifiers? Okay, different types of questions may be asked in these topics. Okay, topic of center tapped full wave rectifier, advantages and disadvantages of full wave rectifiers. Okay, and also may be asked, briefly explain about center tap full wave rectifier. Briefly explain about center tapped full wave rectifier. Okay, different types of questions may be asked in this topic. Okay, prepare well. Okay, thank you.